Okay, it says find the area of the shaded region. Dimensions are in meters. So job one, just take a look, and every time you do this test or every question that you see, you should focus on the question they're asking to make sure that you found what they're asking for. This says find the area of the shaded region. So we're looking for area just of this part here, and there's not enough information we could figure out to figure out the base and height of this triangle to have just the 1/2 times base times height formula for the shaded region. So what I need to do is consider the entire picture, the entire thing is the big triangle. So let's start with that. The height of the big triangle is 7, the base of the big triangle is 10, and we're supposed to assume a right angle here. I didn't mention that, but you should assume that a right angle in this case. So the area of the big triangle is simply going to be 1/2 times 10 times 7, which is 35. That's the area of everything. The entire thing, nothing cut out of it. If I were just looking at that triangle as a whole, that's what the area of the whole triangle would be. Now if we look closely at this figure, we have a triangle here that's being cut out of this whole figure. Its height is 5 and its base is 4. We also have a rectangle being cut out of this. Its base is 4, its height is 2. And finally we have another triangle being cut out of this. Its base is 6, its height is 2. This based on the rectangle here, 4 and 4 and 2 and 2. So looking at those three figures in green, red, and blue that's being cut out of the entire triangle, if we subtract the green, the red, and the blue from everything, which is 35, we'll be left with a shaded portion. So the area of the green, I'll say A sub g for green, is 1/2 times its base times its height. I'm using this formula because the green is a triangle, so 1/2 times base times height, which is 10. Considering the red is a rectangle, the area of the rectangle is just the base times the height. 4 times 2 is equal to 8. And if we're looking at the blue triangle, once again it's a triangle, so the area formed for a triangle 1/2 times its base times its height. 1/2 of 6 is 3 times 2 is 6. So these three areas here together are all being cut away from this area here. So 10, 8, and 6 make a total of 24. That's being cut away from 35. So if we do 35, the area of the whole figure, minus 24, the three pieces that are being cut out of the whole figure, we're left with the area of the shaded region of 11 meters squared. Okay, problem 2. The base of the triangle is the diameter of the circle, and the altitude is the radius of the circle. Find the area of the shaded region. Dimensions are in meters. So we have here a circle that's got a triangle cut out of it. Again, it says find the area of the shaded region. And the area of the shaded region is simply the circle, the whole circle, minus this one triangle. If we look at the circle first, area of a circle is pi times radius squared. This is the center of the circle, 4 up, 4 right, 4 left. They're all radii of the circle. So the radius of the circle is 4. If I do pi times r squared, 4 squared is 16. 16 times pi is about 50.24. So 50.24 represents the area of the entire circle. All the circle takes up a space of 50.24 centimeters squared. What we're trying to find is the area of just the shaded portion of the circle, and what's being cut out of the circle is a triangle. So now we have to find the area of the triangle. So if I focus just on the triangle here, the dimensions that matter to me in a triangle are the base, which is this dimension. If I go all the way across the base, 4 plus 4 is a total of 8 for the length of the base. The height, which is perpendicular to it, is marked as 4. So the area of the triangle is simply going to be 1/2 times its base times its height. Half of 8 is 4 times 4 is 16. So the area of the shaded portion is simply the area of the whole circle minus the one triangle that's being cut out of it. 50.24 minus 16 is 34.24. Dimensions are in centimeters, so that'll be centimeters squared. Okay, so the first two problems there represent shaded areas. Find the area of the big figure, subtract all the unshaded parts, and you're left with the area of the shaded part. Number 3. Directions clearly state, find the perimeter of this figure. Perimeter simply means add up all the sides. So my first task is to determine the length of every side. I can see very clearly I got right angles marked. So if this is 6, this side over here is 6. Now this bottom side starts here, ends here, and it spans the same distances from here all the way to here. So you have to be careful that we include the diameter of the semicircle with the length of the rectangle piece here. So 6, that's 3, and that's 3 for each of the radii. So 3 plus 3 plus 6 is a total of 12 all the way across there. So we got 12 all the way across here. So this side, and this side, and this side, and this side are all the straight edges of this figure. The only other piece we need is this semicircle. A semicircle perimeter is always just pi times the radius. So 3 pi in this case, which is about, if we're using 3.14 for pi, 9.42. I would prefer the decimal answer there. So 9.42 represents the length of this piece here. So if you take a look, this piece plus this piece plus this piece plus this piece plus this piece spans the entire figure. So we just have to add up those 5 pieces to get the perimeter of this thing. So when you get 6 plus 12 plus 6 plus 6 plus 9.42. The only decimal is this one, so if you focus on the whole number pieces, 18 plus 6 is 24, plus 6 is 30, plus 9 is 39. 0.42 is the only decimal part. And dimensions are in meters. Perimeter is always in just units, so it'll just be 39.42 meters for the answer to that one. Number 4 says find the area of the 81-degree sector. Find the area of the 81-degree sector. So it's not asking for the length of the arc, it's asking for how much space is in there, in that piece. And area of a sector is based on area of a circle. So if we start off with the area formula for a circle, leave a little bit of space right here. Pi times the radius squared is the area of a whole circle. What we're dealing with is a part of a circle, specifically 81 degrees of a circle, out of a total of 360 degrees total in a circle. So what we're looking at then is we take the area of the whole circle times 81 3/60ths. In this case, the radius is equal to 6. Radius goes there, and we're going to square the radius because, again, we're using the area formula for a circle because we're being asked to find the area of the sector. So the area of the sector ends up being 81 over 360 times 3.14 times r squared, which is 36. For me, that's what I do, and then I use my calculator to evaluate that. And I would type in my calculator exactly what I see there. I do the divided by 360 last. So I'm typing 81 times 3.14, which is pi, times 36, divide by 360, and we get an area of 25.434. I can go 2 decimal places. Dimensions are in meters. Area is always in meters squared, or square units, whatever type unit we're using. So 25.43 square meters is what I'd go with. I'm fine with 434. Don't round too much, but a couple decimal places is always fine. Okay, number 5. Once again, if we focus on directions, what are we being asked to do in this problem? It says, find the volume of the pyramid. Okay, this is not a pyramid, so the first thing I want to do is see how they describe the pyramid so I can help me find the volume of this thing. It says the base of a pyramid 11 centimeters high is the triangle shown. So this right here, this picture represents the base of the pyramid. If I'm trying to find the volume of a pyramid, I'm going to focus on the volume formula for a pyramid, which is area of base times height over 3. Where B is the area of the base is this, so area of this triangle is going to be B. H is height of the pyramid. It says pyramid 11 centimeters high. So in the words, I've got the height of the pyramid given to me. The base is this triangle, so the area of the base is the triangle area formula, 1/2 times the base of the triangle times the height of the triangle. Half of 12 is 6 times 5 is 30. And that's going to be centimeters squared, in case you wanted to put units in these pieces. What I really care about are the numbers. So H equals 11, B equals 30. All right. Once I know these two numbers, I just apply this formula, which says V is equal to B, which is 30, times h, which is 11, divided by 3. Pyramid and cone has this divided by 3 on it. It's just part of the formula. Do not forget that part of the formula. 30 divided by 3 is 10. 10 times 11 is 110. Volume is always going to be in cubic units. We're dealing with centimeters in this problem, so 110 cubic centimeters is the answer. That came out nice and pretty. If it comes out decimal on the test, so be it. Just go to a couple decimal places. It's usually a whole number divided by 3, so it'll be 0.33, 0.67, or a whole number. So it shouldn't be too ugly of an answer no matter what happens. But you should be given a triangle as the base. You should find the area of that triangle. The height should be given in here. The volume formula is that. That's how you do it. And again, focus on what you're being asked to do. Ask yourself what information you need to do it, and then go about finding that information. Number 6, once again, focusing on the directions. It says find the volume of the cylinder. Okay, this is not a cylinder. It's a rectangle with a semicircle attached to it. So I should be able to read about the cylinder up here to find out what they're talking about. It says, has the following figure as a base. So again, this is the base of the cylinder. I'm seeing that it's asking me to find the volume of the cylinder, so I'm going to focus on the volume formula for a cylinder, which is area of base times height. Once again, I've got two things I need to establish. What does B equal? B is the area of this figure. What does H equal? H is the height of the cylinder. Cylinder 9 meters high, so H equals 9 meters. Okay, again, the number is what's important to me here at this point, so I'm going to leave meters out of it at this point. As far as the area of the base is concerned, notice we have a semicircle with a rectangle attached to it. The diameter of this semicircle, 5 right and 5 left, is 10, which means the piece up here is also 10. Be careful, you have to find the length and width of the rectangle in order to find the area of the rectangle part. So this part of the base is a rectangle. This part of the base is a semicircle. So we have to find the area of the base in pieces and then add those pieces together to get what B equals. So the area of the rectangle is 12 times 10, which is 120. The area of the semicircle is 1/2 pi times the radius squared. The radius is 5, 5 squared is 25. Always square the radius in your head so you don't have to square something on your calculator. It's just easier to type in multiplication. 0.5 times 3.14, which is pi, times 25, comes out to 39.25. If you didn't want to use 0.5 as a half, 1 times 3.14 times 25 divided by 2 equals, that works also. The rectangle 120 plus the semicircle 39.25 adds up to make B. So if we add those together, I get 159.25. Once I know these two numbers, B times H is volume, so volume is going to be 159.25 times 9. And my calculator says that's 1,433.25. At this point, I'm looking at the unit as meters, so that's going to be meters cubed. Again, volume is always in cubic units for a final answer. Number 7, find the volume and surface area of a sphere whose radius is 12 centimeters. It says find the volume and surface area. So we're asked to find two separate things. We need two different formulas to find these two things. And it is a sphere that we're dealing with. So the volume formula for a sphere is 4/3 pi r cubed. The surface area formula for a sphere is 4 pi r squared. In each case, the only thing I need in order to find this information is the value of the radius. Notice the radius is 12 centimeters. They tell us the radius. So, what I need to do then is figure this out. 4/3 times pi, which is 3.14. Now in this case, 12 cubed is not something easily done in our heads, so I would probably write 12 cubed. What I would do if I were you is I would type in my calculator 12 cubed equals 1728, and I would put that number right here. So then what I've got left to do is 4 times 3.14 times 1728 divided by 3. So let's bring this over here so we can see what's going on. I type in 4 times 3.14 instead of pi times 1,728, the value of 12 cubed, divided by 3. Always do the divided by last. That comes out to 7,234.56. The unit is centimeters, so this is going to be centimeters cubed. Okay. Notice I found the volume. I used the volume formula. I wrote V equals, so I'm identifying the volume is this. So I'm not just putting two numbers down and making the teacher determine whether you knew that was volume or not. Make sure you've identified volume as V. Moving on to surface area, our formula is 4 pi r squared. So surface area of this sphere is going to be 4 times pi, which is 3.14, times r squared. The radius is still 12 centimeters. 12 squared is something I know just from my facts that I've learned. So I just go ahead and write 144. And again, this is all I have to type in my calculator to get the answer. So I type in 4 times 3.14 times 144. And my calculator tells me the answer is 1,808.64. Again, dimensions are in centimeters, so that's going to be centimeters squared. And notice once again, it asks for surface area. I wrote surface area equals. So I'm identifying not just the answers, but what the answers represent. Since I'm asked to find two separate things, making sure my paper is labeled properly so that I'm being very clear about what each answer represents. Number 8. Focusing on directions again. It says find the perimeter of this figure. Corners that look square are square. Dimensions are in yards. Now the most common mistake people make on this problem is they want to add this semicircle and subtract this semicircle because that semicircle goes inward. What you have to realize is if I'm walking around this figure, if this is a pool and I'm walking around it, I don't want to get wet. I'm going to go here. I'm going to go around this semicircle, adding distance, go down here, over here, up here, adding distance, going here, adding distance. And from here around to there is adding distance to my walk. So anytime you're adding distance, you're going to be adding the side representing that distance. So both semicircles are increasing the length of my walk around the pool, so therefore I'm going to include those. The other part that messes people up with this specific problem is there's no way to determine how long this piece is or how long this piece is individually, but together from here to here, matched up with here to here, should be the same distance as this right here. So that's 8, so these two together make 8. I don't care what you make it. 1 and 7, 2 and 6, 3 and 5, do what you want to do. I'm going to say 4 and 4. 4 plus 4 makes 8, 3 plus 5 makes 8. It doesn't matter what they are individually, just as long as these two together make the same as that piece there, because together, those two pieces make the same length as the bottom. The semicircular pieces have a radius of 3. So this is 3 pi, better known as 9.42. If we approximate pi as 3.14, same deal here, the radius of 3. So 3 pi, which is about 9.42, using 3.14 to approximate pi. I do not add that radius because that's not part of my walk around the pool. This radius is. That 3 also is. So if I'm adding up all these sides that increase my distance around this weird looking pool that we have, 9.42 plus 8 plus 9.42 plus 3 plus 4 plus 3 plus 4. That's all the pieces that I have to add up. I would probably get the two decimal numbers, 9.42 plus 9.42 makes a total decimal value of 18.84. The non-decimal numbers are 4 plus 3 plus 4 plus 3 plus 8. 7 plus 7 is 14 plus 8 is 22. 22 plus 18.84, adding a decimal point like that just gets me 40.84. Corners look square, square dimensions are in yards, and perimeter is just in units, not to any power. So P equals 40.84 yards. You should expect a similar looking figure. I'll have some different numbers on there to get different answer, of course, but both semicircles, one going out, one going in, they both have to be added up. The two missing pieces have to add up the same as the bottom piece there. That kind of stuff's going to be happening on the test. Okay, number 9 moves on to vertical angle properties and also straight line properties. So let's just focus first of all on a straight line. This straight line right here has 180 degrees in it. these two angles, 60 and Z, together form that straight line. So I know for a fact that Z plus 60 has to be 180. Straight line always adds up to 180. So therefore Z must equal 120 because we moved the 60 over to subtract. And there's one of my answers. Find X, Y, and Z. Z is 120. Once I know that Z is 120, I can scribble that out and put 120 in place of it. The next thing I know is vertical angles are equal. What that means, I have these two intersecting lines. This angle right here has to equal this angle right here. Similarly, this angle right here has to equal this angle right here. So I know for a fact that 5x is the same as 60. Okay, 5x, x doesn't equal 60, 5x, the angle measure here, matches the angle measure here. I'm supposed to find x, so if it says 5x equals 60, I divide by 5 to find out that x equals 12. In the same manner, 2y has the same angle measure as 120. So I know for a fact that 2y must equal 120. Divide both sides by 2, because I don't care what 2y equals, it says find y. So 2y is 120 divided by 2, that means y has to equal 60. Make sure you're finding x, y, and z, not 2y, 5x, and z. Make sure you find what they're asking you to find on those problems. There will be some division necessary for some of that. Number 10. It's asking us to find the measure of the angle. Okay? If they're asking us to find the measure of an angle, I need to know what properties or characteristics this angle has in order to find out what it is. It says the complement of an angle is 23 degrees. This word complement means that two angles add up to 90 degrees, which means the complement that I'm looking for plus the angle they gave me should add up to 90 degrees. Because again, complementary angles add up to 90 degrees. What I don't know plus what I'm given equals 90. Subtract 23, we end up with C is equal to 67, would be the answer to that problem. Number 11, similar type of question. It says, again, what is the measure of the angle? So we look to see what kind of description they give us for this angle. This one says the supplement of an angle is 121. So now we got this word supplement. And angles that are supplementary add up to 180. So the supplement, the angle I'm looking for, plus 121, the angle they gave me, should equal 180 degrees because the word supplement means adds up to 180. So to get the answer, I simply move the 121 over here and subtract. We end up with an angle measure of 59 degrees. So 10's complement, 11's supplement. Again, know what they mean. The easiest way I know to remember, because one's 90 and one's 180, complement starts with C, supplement starts with S. C comes before S, so the smaller number C, the bigger number S. If you're thinking about alphabetical order, other than that, complement has one P, supplement has two P's, so it's twice as big. I don't know. Use some way or just remember the words. Complement's 90, supplement's 180. Number 12, we're supposed to simplify this expression following the order of operations. I've got some grouping symbols here. I've got some absolute value bars, which kind of fall into the category grouping symbols. All this stuff's being multiplied, this is being subtracted, that's being added. So basically you have three pieces to this problem. So I can work with this at the same time I work with that because they're so far away from each other they don't affect each other. That's legal. So if I focus on this whole thing here, I'm going to focus first off on this part here. So the -3 I'm leaving alone. Inside this parentheses I have underlined in blue. It says -5 squared minus 5. Powers affect numbers, not signs. So that's 5 squared, not -5 being squared. So minus is still minus. 5 squared is positive 25. Attached to the minus sign, making -25 minus 5. Powers happen before subtraction. So -5 squared happened first. The subtraction will happen second. This -6 is not doing anything, so I'm not going to do anything to it. And then I got plus the absolute value -4, which is just plus 4. Absolute value bars make things positive. The plus sign occurs after that happens, so plus 4 is what you get out of that absolute value expression. Next thing, still working within the parentheses, I can't make -6 or plus 4 any simpler than they are. So working within these parentheses, I got -3. I have to make a decision, should I add or subtract? I base that on the signs of the numbers I'm looking at. These numbers are the same signs, so I add. Even though it says minus, I add because the signs are the same. 25 is bigger, so it's negative. Then I got the rest of this problem as is, negative 6 plus 4, or minus 6 plus 4 actually. Final step before addition and subtraction happens within the order of operations is multiplication. Negative 3 and negative 30 make 90, then I got minus 6 plus 4. Once I've got this whole thing simplified, this first part simplified completely, now I'm left with just addition or subtraction. If I go from left to right, 90 minus 6 is 84, plus 4 is 88. You should expect a similar structure. There'll probably be some negative sign, a negative number raised to some power. The power affects only the number, not the sign. There'll be an addition or subtraction decision there. There'll be a multiplication followed by addition and subtraction for the whole problem. There'll be some absolute value over here that has to be dealt with individually. Number 13, we have, once again, simplify. Once again, we have some absolute value bars. This time, we got stuff inside absolute value bars and just a number. All right, so, and once again, it's separated by a plus or minus sign, so this does not affect this and vice versa. Now, one other thing you want to notice before you start simplifying this is this minus sign is out in front of the bars. This minus sign is out in front of the bars. So, the minus signs that I have circled in blue are going to stay there. What I have underlined here in purple, before I do the absolute value bars, I have to evaluate inside to a single number. 7, 4, and 2 are all negative numbers. So I don't subtract because I see minus signs. I'm going to add because I see all the same sign. 7 plus 4 plus 2 is 13. They're all negative, so negative 13 goes in the absolute value bars. Then I've got this minus sign here. And inside this other purple, this is just absolute value of negative 5. That's just 5. So that part made the 5. The minus sign is still there because the absolute value bars don't affect that minus sign. Similarly, I got this minus sign right here. I'm just bringing it down. The absolute value of negative 13 is simply 13. So the absolute value bars made this become positive. This minus sign takes effect after the bars happen. I've seen people see minus minus makes a plus kind of thing there. Be careful, the absolute value bars happen first. The minus sign happens second, so it's still attached. I have minus 5. We've already dealt with the absolute value bars there. I'm left with minus 13, minus 5. They have the same sign, so I add. Again, when you have to decide, should I add or subtract? If the signs match, you add. If the signs are different, you subtract. 13 is bigger than 5, so we get a negative answer. Always go with the higher numbers sign when you're adding or subtracting. Number 14, we've got these brackets here, which encase this entire expression here. Inside the brackets, we have this absolute value expression minus this power expression minus this negative number. So this and this and this are dealt with individually. Then I add or subtract, again making decisions based on signs about adding or subtracting, get a single number in here. That result, whatever that result is, multiplies then by negative 2. That's the order that I would do this in. So this negative 2 out in front stays right out in front. I'm going to put a big bracket because I'm not doing the whole bracket yet. I'm going to do pieces of it. If I focus first of all on the absolute value expression, I've got absolute value bars. I don't do the bars until I get a single number. Looking at the numbers inside the bars this time, negative 2 plus 6 minus 9 comes out to negative 2 plus 6 is 4, subtraction because the signs are different. 4 minus 9 is negative 5, also subtraction because the signs are different. So all the stuff inside there adds up to negative 5. We'll do the bars in the next step. I got minus 2 cubed. 2 is being cubed, the minus sign is not. So it's still minus. 2 times 2 times 2 is 8. Then I've got minus negative 4. Minus negative 4 is simply plus 4. Then we end the bracket. The absolute value bars, now that I've got a single number inside, take effect. The absolute value of negative 5 is positive 5. Once I've done that, inside the brackets here, 5 plus 4 is 9, minus 8 is 1. These have the same sum I add. 9 minus 8 have different signs I subtract. 9 is bigger than 8, so it's positive. And once I got the brackets figured out to a single number, I multiply those two together. Negative 2 times 1 makes negative 2. It's negative because we have different signs. When you multiply what you see. The signs different get you a negative. The signs being the same would get you a positive. And finally, number 15, we got this big fraction. We got stuff on top, stuff on bottom. The top should get down to a single number. The bottom should get down to a single number. So you should assume a bracket on top to get all that down to a single number, a bracket on the bottom to get all that down to a single number. They don't affect each other until you get to the final step where you have number over number. Then you reduce the fraction. So looking at the top, I got -3 minus, okay? In parentheses, -4 minus 15 is -19. Notice I added the numbers because the signs match. Then I've got minus. And in the second parentheses here, I've got -3 plus 7. That's going to make 4. 7 minus 3. They're opposite signs. I subtract. 7 is bigger, so it's positive. Okay, if I continue working the top down as much as I possibly can, -3 is fine the way it is. Minus 19 is plus 19 minus 4. -7 plus 19 makes 12. Negative sum of 7, positive sum of 19, subtract to make a positive 12. That's the top. If we look at the bottom, I've got -2. I've got 3 squared minus 8. That's 9 minus 8 times -2. Notice I just evaluated the 3 squared first. It's a power inside the brackets. That happens first. -2 is still -2. 9 minus 8 equals 1 times -2. Now that I got the bracket worked out to a single number, number times number times number. We multiply the 3 numbers. 2 times 1 times 2 makes 4. 2 negatives makes a positive. So the top is 12. The bottom is positive 4. 12 divided by 4 is equal to 3. There's your answer. That's how you work out a rational expression like that, to simplify it.